Assalamu alaikum warahmatullahi wabarakatuh. This is the first presentation on fundamentals of structural mechanics. So first we'll talk in general how to calculate stress. So if we're talking about a 3D problem and we have axial force and moments about the x, about the z and about the y directions. So simply sigma x equal p over a plus mz times y over iz times my times z over iy. Iz and iy are the moments of inertia about the z and y directions. Mz is the moment about z, my is the moment about y. Distance y is the distance, the farthermost distance from the centroid to the farther distance to the uppermost point or lowermost point of the cross section. Same thing is for z for the other direction. So z is the farthermost left or farthermost right distance. P is the axial force and A is the area. However, in case of a truss, we don't have moments. So simply sigma is equal to P over A. Meanwhile, in case of a 2D beam, we don't have axial force and we only have one moment about one axis. So sigma will be equal to mzy over iz, or it could be rewritten as mz over sz, where sz is the section modulus, which is simply equal to iz over y. However, in case of a 2D frame, the combined normal stress due to axial force and bending moment, however now it's bending moment about only one axis, it is P over A plus mzy over iz, or P over A plus mz over sz, again where sz is the section modulus, which is iz over y. So let's take a very simple example. This is a very simple truss, two members. If the maximum allowable stress due to the material property is 165 megapascal, will rod BC withstand the loads shown, knowing that the diameter is 20 millimeter? So in such a case, we will simply analyze the truss. So first we will get the reactions AX, AY, CX, CY, and from the equilibrium equations, we'll find that AX equal 40 kilonewton, CX equal negative 40 kilonewton, AY equals 0, and CY is equal to 30 kilonewton. So then we'll solve joint B by the method of joint. Sigma Fy equals 0, which is equal to 0.6 FBC minus 30, because you take the vertical component of FBC. So FBC is equal to 50 kilonewton. Then sigma Fx equals 0, equal negative FAB minus the horizontal component of FBC, which is 0.8 times 50. So FBC is equal to negative 40 kilonewton. Then we'll apply our equation. Sigma is equal to FBC over ABC. Why did I pick FBC? Because FBC is the largest force. So 50,000 over pi r squared over 4, or pi times 20 squared over 4. So this will give us 159 Newton per millimeter square. And by the way, 1 Newton per millimeter square is the same as 1 megapascal. Newton per millimeter square is a megapascal. So that means that the structure is safe. The member is safe. Let's take another example. Here we have a wooden beam under that loading with a cross section of 250 millimeter by 80 millimeter. So first thing we'll calculate the reactions. They are 46 kilonewton and 14 kilonewton respectively. Then we'll draw the shear force diagram. If we take a section anywhere between A and B, you will find a shear force of minus 20 kilonewton. Then the 46 kilonewtons takes it up from minus 20 to plus 26 at point B. Then anywhere between B and C, it is the same 26 kilonewton. Then it drops by 40 kilonewtons, so it becomes minus 14. Then the minus 14 comes up to 0 at the support D due to the reaction. Then if I drew the bending moment, you could draw it by calculating the area under each of the curves. So simply the area of 20 times 2.5, so this is minus 50 kilonewton meter. And from the other side, minus the 14 times 2, this is 28. So you could simply connect them together. Or you could take a moment at B, you'll find 20 times 2.5, this is minus 50. And take another moment at C, you'll find 14 times 2, which is again plus 28, and then connect them with a straight line, because you know that all of these are straight lines due to the shape of the shear and the relation between the shear and the moment. So the moments must be straight lines because the shear forces are constants. So due to that, if I want to calculate the cross-section property of the moment of inertia of the rectangular section, I will find that I is equal to BH cube over 12, which is equal to 80 times 250 cube over 12. This is 104.16667 millimeter power 4. So sigma max is equal to my over I. Y is half of the distance because the cross section is symmetric. So 250 over 2 is 125. I'll multiply it by 50 million. Why 50 million? Because the maximum moment was negative 50 kilonewton meter. So 50 kilonewton meter, this I will make the kilonewton newton, so I'll multiply by 1000, and the meter I will make it millimeters, so I'll multiply by another 1000, so that's a million. Okay, so times 1000 and times another 1000, so this will make it 50 million, divided by, of course, the I. So now my units are consistent. It's Newton and millimeter. So now I will find that sigma is equal to 60 Newton per millimeter square, or 60 megapascal.